All right, so again, lesson 14 in module 3 here is on solving inequalities, and that's what we want to focus on. So we're talking about this carnival, excuse me, and it says a youth summer camp has budgeted $2,000 for the campers to attend the carnival. Now, the cost for each camper is $17.95, and that includes general admission and 2 meals. Now, this youth summer camp is paying for these kids to go to the carnival, but they also have to pay $250 for the chaperones, and they have to pay $350 for transportation. So how many campers can they take? They only have $2,000. Okay? So they have $2,000, and they know they're going to have to pay $17.95. Now, this is where I got messed up in the last one. When you see for each, for every, per, okay, 95% of the time, except that last problem, right? That means that that is our constant, our unit rate, the number we're multiplying by. Okay, so I know that I'm going to have to pay, or the camper, or the youth camp here is going to have to pay $17.95 per camper. So one camper you multiply by 1, 2 campers you multiply by 2, 10 campers you multiply by 10. So I'm going to take 17.95 times, and I'm just going to use x. Okay, so whatever that ends up being, plus $250 for transportation, plus $350 for, I'm sorry, $250 for chaperones and $350 for transportation. Let me spread this out a little bit. I can't go over 2,000. That's it. That's all I budgeted. So if I can't go over 2,000, that means I have to be less than 2,000. But can I spend exactly 2,000? Yes. That's what I have. I budgeted 2,000. I just can't go any more than that. That's why we say it's less than 2,000. All right, so now simplify and solve just like we would an equation. So if I'm looking at each side of the equal sign, over here I have some like terms. I can add 250 and 350 together. And when I do that, that's 600. So I end up with 17.95 times x plus 600 is less than or equal to 2,000. Now, what are we solving for? We're solving for the x term. So I have to get rid of this plus 600. How do I undo adding 600? Subtracting 600. Whatever I do to one side, you do to the other. Sound familiar? Remember, just like solving an equation. I bring down my 17.95 times x. Double check here. Are these opposites? If I took a calculator and added positive 600 plus negative 600, would I get 0? Yes. Bring down my inequality symbol. 200 plus 2,000 plus a negative 600, or 2,000 minus 600 is 1,400. All right, so how do I undo this multiplication now? I divide. Whatever I do to one side, I do to the other. 17.95 or $17.95 divided by $17.95 is 1x. If you grab your calculator and take 1,400 or 1,400 and divide it by 17.95, you get 77.9944, blah, 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 blah. Okay, let's come back to that. Now, the last thing I do, the only difference from solving an equation, is I ask myself, all right, I divided. Okay, nothing wrong with that. Was it by a negative number? Did I divide by a negative number? Nope. So my inequality symbol is preserved. Okay, now let's think about this here for a second. Okay, this rounds to 78. But if I plug 78 in here, I'm going to go over 2,000. So we can't think of this as just rounding to the nearest whole number unless it says that. All right? Because if I type in my calculator right here, 17.95 times 78, right here, and then I add the 600 to that, it ends up being with 2,010 cents. Now, let's be honest. Would we probably kick in 10 cents? Probably. But we're not in charge of that right now. Okay? It goes over 2,000. Remember I said we can't go over 2,000. So our answer is x is less than or equal to 77. Don't just put 77. It's not 77. It's any numbers less than or equal to 77. So your answer needs to start including this whole thing. And in fact, it's always good to write it out. We can invite 77 or less campers. All right? Those are the new things. It's kind of like we're always adding on something, right? Let's look at one more example. Now, the carnival owner pays the owner of an exotic animal exhibit $650 for the entire time the exhibit is displayed. Okay, so the carnival, have this carnival here, they're going to pay this exotic animal exhibit, this person who runs it, to come in. Here's $650, show your exotic animals. Now, the owner of that exotic animal has no other expenses except for a daily insurance cost. Okay, now they want to make more than $500 in profits. And remember, it runs for 5.5 days. So what's the greatest daily insurance rate? It's exotic animals, you better have some insurance, right? What's the greatest daily insurance rate he can afford to pay? Okay, so what is he making? If I am the owner of the exotic animal exhibit, I am getting paid this $650. Sweet, right? Bring my exotic animals in, okay? But I have to pay my expenses here a daily insurance cost. How many days am I paying that daily insurance cost? 5.5. I'm going to write it as 5.5 though. Okay. Now, is that being added on to my $650 or subtracted from? Yeah, subtracted from, right? And am I only paying that $5.50 or I'm not $5.50, I'm sorry. That 5.5 days, am I only paying insurance rate once? No, I'm paying it per day for 5.5 days. Okay. Since it's a daily rate, I have to multiply this, and I'm just going to multiply it by X. Okay. So if it's $10, I have to pay $10 for 5.5 days. If it's $20, I have to pay $20 for 5.5 days. If it's $100, I have to pay $100 times 5.5 days because it's the daily rate. I want to make more than $500 in profit. More. So this has to be greater than. Okay. So can it be equal to 500? Is 500 more than 500? No. So we're just going to leave it as greater than. Okay. So now let's do what we do and let's solve this, right? So I have to solve for my X term. Now, do you see this minus 5.5 times X here? Let's make that into plus a negative, okay? Because this is negative and we can't forget that. So I'm going to solve for this whole term, which means I have to get rid of the 650. What can I combine with 650 to make it go away? Negative. Or think of it as subtracting. Whatever we do to one side, we do to the other. These give me 0. I bring down my negative 5.5 times X. I bring down my inequality, and I just type that into a calculator, or if I know it, it's a negative 150. So now I've solved for my X term. I need to solve for X. This is negative 5.5 times X. I undo multiplying with dividing. And we've already talked about why if this is a negative 5.5, we divide by a negative 5.5. Whatever I do to one side, I do to the other. Same things over and over. This works out to be 1x. Then if I type this into a calculator, negative 150 divided by negative 5.5, I get 27.27 repeating. Now, last thing I do before I bring that on that inequality, I ask myself the question, did I multiply or divide? Yes. By a negative number? Yes. You can answer yes to both those questions, okay? Doesn't matter if it's multiplication or division. Doesn't matter if the answer is positive or negative. If you divide, divided by a negative, divided by a negative. If you divide by a negative or multiply by a negative, that's when we reverse that inequality. So instead of saying greater than, I'm saying less than. Now, I can't really pay a repeating rate here. So remember, I can't move it up, okay? This has to be less than this. So I am just going to round it down to $27.27. Okay, so this right here, because again, look at my answer has the X in it. Okay, this right here is the greatest daily rate, daily insurance rate he can afford. Okay, that's it. If he wants to make $500, that's it. Okay, one last piece of advice. Remember, when you multiply or divide by a negative number, reverse the inequality sign or symbol. Okay? Only occurs with multiplying and dividing, and it doesn't always happen to be multiplying or dividing. It's only when you multiply or divide by a negative. That's the only difference from solving an inequality to solving an equation.